So today let's take a look at this HD12, this 12 amp hour high output M18 battery by Milwaukee. We see that this is a manufacture date of 21, so this is not an old battery at all, and it gives us the typical one blinking LED. Usually that means there's at least one cell group in there that's reading low. We're going to start off with a T10 Torx bit, and these are the security type with a little stud in the center of the screw. So T10 security, and we'll fast forward through some of this. Too long and too short, and we're in. And right off we do see a big difference between this pack and some of the smaller packs with this huge heatsink. Let's get into it further here. We got 4 T8s on the bottom. Once we remove these 4 T8s, the whole pack just slides right out. This pack is in excellent condition. This pack was given to me by a friend, by the way, just so we could look at it and investigate it and maybe have parts. So I appreciate Ronald sending this in to us. We'll go ahead and measure the voltage across the terminals here, plus and minus, like so. 18.2 volts. We shouldn't be picking up a low pack voltage, but if we go all the way back, yeah, 18.2. So the voltage is going all the way through. The next step is to look at these individual cells, and I'm going to look at the spot welds here, and everything looks great. No spot welds are loose. Of course, a loose spot weld could really give you some issues, and not the most common issue, but it is an issue with some of these packs. So we go across the individual cell banks. 3.57. That's about exactly what the pack should average. Oh, 3.09. That is not good. That is getting close to cutoff voltage on those cells. Then we got a bank that's almost fully charged at 4.06. 4.06. At least we got some good cells here. 4.06. Awesome. And 3.42. So we do have a pretty unbalanced pack here, which is sad. These are some excellent cells. Looking forward to looking at these 21700s. I haven't had a pack with 21700 cells go bad yet. So we see here we have the 3 connected together in a group like so. This will be 4 volts, then here, then it'll be 8 volts on the other side here. Connected 2 coming back through, which will be 12 volts. Connected through and coming back through, which is our 16 volts, and finally coming back through here to our 20 volts and going straight out to the positive terminal. So yeah, we go back looking at this next to the last cell in the back. This group here is definitely bad, and these reading lower than fully charged have probably got at least one bad cell in that group also. We know we got to concentrate on these, and more likely it's 3 to 4 bad cells in this pack if I had to guess from experience on other packs. So this is my first time with a 12 amp hour pack to say for sure. I'm just going to put a little charge on this lowest cell group. So we'll go over to our constant voltage and constant current power supply and set it for 4 volts. 3 amps max out, which should be fine with 3 cells in parallel. And we're charging right at 8 watts or so. So we'll put less than 10 watts in. We'll see how the heat does on these cells. Back now after letting it charge for a little while. And they are getting a little bit warm, but does our error clear? It does not. So I'm going to pull up the microcontroller spec sheet for this package and look at the reset terminals. And I had to dig hard to find something really fine to get to this fine a pitch, but I'm going to try to do a reset on the microcontroller just to see if it'll clear my fault on these pins here, 2 and 7 in this case, on this microcontroller. And no change there. So one after the video edit coming in here, guys, is I could have put this pack on the charger and it may would have reset once the voltage started rising, but these cells do drop really quick So I do know I have a sale issue, so I'm going to go ahead and continue tearing into the pack. So I'm going to use my Wick's electric screwdriver here and remove all 4 of these little #1 Phillips screws and take off this heatsink. And we do see a thermal pad under here. Take off the thermal pad, and I do not see transistors. It would be odd if they're on the bottom, but I guess they could be. This is more like a cooling plane or pads for the cooling of the MOSFETs, assuming that there are some. With this heatsink, I'd be surprised if it wasn't. So we do know we have several bad cells in here, the way that it's dropping off, and we're pretty sure we have MOSFETs under here. As we remove the heatsink, and we see the cooling pads here, and this board is unlike any I've ever seen before. But the odd thing is they do sell aftermarket kits that's very similar for the 12 amp hour, and believe it or not, they're even for the 21700 cells. And if you look how big this board is, it does look like this knockoff board might be a very similar size, which is surprising to me. But if we just look on their images off Amazon, on the back, it does not have MOSFETs. It is simply joining where the negative of the battery cells goes all the way out to the terminal output of the pack. So I'm going to go ahead and remove the power from the board coming off the pack by removing these spot welded tabs for the negative side and also for the positive side of the pack, and just raise these up, which these are just 2 or 3 spot welds. These are very easy to remove. So I want to go ahead and remove this board now because I want to look at the MOSFETs on the bottom side. I don't want to miss the opportunity here to investigate this board better. Very careful here not to touch any other parts of the cell groups together with anything metal like our cutters here. Careful to only touch one strip at a time. And here we go, we got the board off. Now let's pull off the heat sink. We have some more thermal pad here and some type of plastic spacer frame here. And under the thermal pad, we definitely have MOSFETs. Let's take a closer look at the board here. We definitely see a Q49 and a Q50, and I can't find anything on these MOSFETs, no information whatsoever. This left part here looks more like the charging circuit. On the back side here we see the processor and fuel gauge. Let's take a closer look under the microscope here, starting with the connectors. We got B+, J1, charge, J2, battery minus. And what we have here is a little ultra small, I agree with that, high side MOSFET driver. It's actually not much bigger than the little ceramic capacitor here. As we move on up, we see a fuse, a MOSFET here that I believe is for charging. I believe this is the charging control circuit. As we come across here, this is where our MOSFETs are on our negative rail up underneath here. We see a fuse here, or probably a PTC there. Then we're starting to see a chip here. This is a 3 to 6S lithium battery monitor chip with the analog front end. This is a typical diagram you see, simplified schematic of it here if you're interested. So they are doing some monitoring with this chip, which is pretty cool. We've got some pretty big ceramic caps here close to the NTC for the cell monitoring, as you can see there. Getting close to our push button and our fuel gauge LEDs coming downward here. And then we see our processor, which I shared a brief bit about earlier when I was trying to reset. I just simply looked up this data sheet and pulled up the pinout for this one. Earlier when I was trying to jump pins 2 and 7, as you can see they're very close together. But putting them on the charger would have been a better reset for the Milwaukee packs after the fact. We're back to our cell monitoring chips here. Let's flip the board over. Not a whole lot on this side, a lot of test points, but these are pretty interesting here. These are PTCs, and they're bigger than 1206 package. As I try to look up the number here, it looks like it's these Bell Power Solutions PTCs. As we take a brief look here, dimensions wise, the 150/24. And if we copy and paste this part number and look in DigiKey, we see that they're fairly cheap at less than $1/4 a piece, and plenty of them in stock, so that's really cool. We also see that we are 1812 size and 24 volt 1.5 amps, so I thought that was interesting. I don't see a tremendous amount of those, but you do tend to see them more and more. This is our NTC just in a silicone potting here. It's just a little black bulb type NTC is typical for the cell temperature monitoring. Here's an up close of our Q49 and Q50 MOSFETs. Try to get a little better look at the part number here. You can see that it's a 7L72 JZ70 and 2021 week 15 of production, so fairly new pack to cost this much and be giving trouble already. This is not the exact MOSFET, but I wonder if it's close because this is a direct FET. It has the metal can, and it seems to have the same mysterious layout because I can't seem to find anything but the drain for testing on the MOSFET. And if we go on down here, let's see if we can find the footprint. And here we go, and this is why it's so hard to troubleshoot. Yeah, the drain's on the outside, the source is under, as well as the gate. So this is probably a BGA MOSFET, so go figure. But everything looks very similar here with direct FET part marking, but this must be a custom part made for TTI because I can't find anything with that part number search. But I have seen similar direct FETs before, and I'm going to have to assume at this point that that's what it is. I want to show real quick here up close of what I was talking about earlier. Only 2 little spot welds on the tabs, which it may have been 3 spot welds here. I might be wrong, but still, I guess that is your weak point. That's your link if something goes wrong, because you can see here we have 12 strong spot welds on the thicker metal, and the tabs just had a couple. So I have seen those break away in the past when a pack this big gets dropped from a distance. So just keep that in mind. So we talked about the PTCs and this little NTC still in the potting here, as you can see. And I think I'm just going to go ahead and take a look at these cells and do individual testing on them and put it through a testing procedure and see how many test good. I'm going to use these little flat nose pliers. Mine came from a Cobalt set years ago, similar to this little set here if you're interested. I'll also put a link down in the description below if it helps. You can also find some like these Speedworks that'll probably work just fine as well if you're interested. We're just going to be very careful not to let anything metal touch any other part of the cell groups, like right here for example. Look how close that's getting. So I'll even put my finger there to make sure that nothing touches, because that would be 4 volts of potential across those 2 spots, and depending on the spots you go across, it could be up to 20 volts of course. I'm going to speed through the video here of just taking off these nickel strips. The same procedure. I like a small and then a little bit larger flat. And then these flat nose pliers is typically what I use to get the job done. We just be careful not to touch anything again from cell group to cell group. I always pull it away. And once we get all the strips loose, this connecting the cells together. This pack does have T10 screws holding the plastic cage together. There's 4 of them in all. That was pretty simple. And there we go. There is our 21700 cells. So these are the Samsung INR 21700-40T. Awesome. I'm going to take all of these out and I'm going to put them in a charger and put them through a test procedure. A very similar procedure that I mentioned in my lithium battery FAQ number 1 video. This Opus charger actually is not designed for 21700 cells. I think it was designed before they even came out actually, but the spring tension is totally gone, but they do barely fit in there. It does match the spring completely out, but I'm going to go through and do 4 at a time. And as we select our slots here and select all slots, Then we can select our mode, which we'll go through here. I'm just going to do a charge test, but I will go through and show quick test, which we'll do that as well. You got discharge test. We're going to go back around here to charge test. If we hit the slot button again, it's going to start doing our charge test where it charges it up, discharge it, and give us our readout in milliamp hours. It's 500 milliamp hours set. We can go up to 1,000 with this charger. So I'm going to painstakingly go through and charge all these up and write the results on the cells, and we'll be back at a later date. So back now, I have tested all 15 of these cells and wrote the milliamp hour rating on them, and they're all very, very close, very surprising. Even the ones that didn't want to show charging very well on the bench, individually and slowly they did charge up to show a decent capacity, and all of them between like 3,800 and 3,950 or so milliamp hour rating. When I did the quick test, which checks the milliohm internal resistance of the battery, I was getting less than 50 on at least one out of the 3 tests I did on each cell. So I would write that down if I got less than 50, because I can't even expect the contact points to be really any less than 50 milliohms. So I consider that as good. And as you can see, all these are very similar. But like I mentioned in that FAQ number 1 video, I do let cells sit after I've tested them. So we're back now a month later with all these fully charged, and these on the right here are there for a reason. When I test these are lower. So these 4 on the right are lower than the 11 on the left side. And I actually have them in order from top left down over of highest voltage to lowest voltage after 1 month of storage after fully charged. So if I bring my meter over here, I'll start up on the bottom left over here, and these will get a little bit higher as I go up here. All these tested very close, and they was all charged up to 4.15 volts. And as you see here, 4.11, very good. 4.11, 11, 12, 12, and almost 4.13, so excellent. And here we have 4.11, 4.08, 08, right at 08, and 407. So those are still really good too. Very little difference in all 11 of those, and I'm very happy about that. I can make a 2S pack and still have 1 spare cell. Awesome. Now these right here is where it changes a little bit. At the top, this one here is not far off. We're just under 4 volts really, 3.96. It's kind of borderline, but you know it is going to pull your other cells down as it drifts as well. So I really wouldn't want to use it. And then these last 3, 3.44, 3.4, and 3.38. So that's terrible. So I would not use these at all. Just sitting there for a month, and they pull down really close to your cutoff point, because a lot of your brands, including Milwaukee, shut off just under 3 volts. So these batteries will sit there and easily get below the 3 volts. The reason I'm happy to get my hands on the 21700s, I don't have many of them, and as you can see here, for a little bit of size difference, we do have a lot more capacity with these cells. So instead of 18 millimeter diameter, we're 21, and instead of 65 millimeters long, it's 70. I think the last 0 in the designation is for cylindrical cells, but we definitely see they're bigger, but they do have a better capacity and sometimes more current producing capability. So if I look these cells up on 18650 Battery Store, we see that you can really get these cells for a good price. We're looking at $5.99 for the 40T3, which I don't really know what the T3 is. These just said 40T, but the one in the picture just says 40T also. But it does have a 3 down below it, below Samsung. We do get a price break here, which we'll talk about later. We look at some of the specs here. One interesting thing is, like most, they show 2.5 on your discharge cutoff and 4.2 maximum voltage. So that's where they get their nominal from, and that's probably where they base the 4,000 milliamp hour from, is 2.5 all the way to 4.2. So ours is showing a tad bit less, but still high percentage. But our test didn't run down to about 2.8 volts, so that's one reason. As we look at the Samsung data sheet here, it's surprising that it shows the new 40T. So I want to research this a little bit. We show some comparisons here between 40T1 and the new 40T. We see the T3 again. I mean, the specs are almost identical. Leads one to believe they may have had some issues and changed some part of the cells, or some process anyway. Yeah, temperature versus discharge. I mean, I don't know enough about it to say, but that looks pretty similar. I still don't see anything that's really stands out. Well, until now. So, okay, so 10 amp cycle life. If you look at the 40T1, wow. So the new 40T, that is a huge difference. Their capacity drops off tremendously on the older version 40T1 after just a few hundred charge cycles, which you wouldn't expect it to drop off that significantly. Very interesting. As we look at the 50 amp cycle, which that's a lot of current, and off of 3 cells in parallel like this, that's a lot of current. But you see, even at 100 cycles on the bottom right horizontal bar there, yeah, it drops off, and it starts dropping off at even 10, 20 cycles. The capacity goes down terribly on these cells. So the reliability test is where we see an issue for sure with the older cells. As far as low temperature discharge, they're close enough to the same for me. Storage, I mean, maybe a little. So the question is, do we have the good one or the bad one? The old or the new one? And according to this, and there's 3 indication on the cell itself under Samsung, ours does not have that designation. Even though it's a fairly new pack, we still have the older style 40T cells. So what a bummer. Looks like those new T3 ones are excellent, and the regular original 40T maybe not so much. I don't have enough experience to say. Obviously, I'm just going by what you just seen there with me on the company's own spec sheet. So I'm also concerned about this board, and I'll show you why. If I ohm out, as I mentioned a little bit earlier about the MOSFETs across here, I'm getting a short, and with the board removed, I wouldn't think it's supposed to be shorted, because this is your minus on the terminals, on your output terminals, all the way back to your minus on your battery pack. They put those MOSFETs there obviously for a reason, to interrupt power if something goes wrong. A little bit different design, but TTI has done this with Ryobi stuff for a while, and I find those packs being problematic sometimes with the MOSFETs, but this is a totally different design, I'll give them that. This is the first for me. A little bit concerned about how the board is showing shorted or 0 ohms across the minus rail there. So I don't really want to use the board, and I really don't want to use 4 of these cells. So what I've done here to hopefully make the video have a good ending is I have bought an 8 amp hour, and many of y'all probably know that the 8 amp hour high output is supposed to also have the 40T cells. So even though this battery is in pretty bad shape, I knew it was broken and busted up when I bought it. I thought if nothing else, I could either take some of these cells and maybe get the 12 amp hour going. That was in the best case scenario. The worst case scenario was taking the good cells out of the 12 amp hour and at least getting the 8 amp hour going, as having some spare cells. So as we take this battery pack here and look at it, we're getting the same blinking light. So we're going to probably have some cell issues or bad connection inside this one also. We see here that it is, as I said, a high output 8 amp hour, and this is actually a 2019 production run. So it definitely should be the same. I'm going to call them the older or bad cells. I guess the correct way of saying it is the earlier version cells. As we measure our output terminals here, we are getting 15.5 volts. That's high enough to charge. So the charger must be picking up an issue with one of the cell groups inside, because as you see here, we get our red and green flashing battery defective light on the charger. And I tried it multiple times. As you can see here in the top left, I I try to put it in the charger multiple times, as I did the 12 amp hour before the start of this video. Well, right off I do see a disappointment with the 8 amp hour pack. Well, we'll get into that in a minute. The first thing let's look at here is the difference in the boards. Even though they're both supposed to be the same cells, it's got the longer board with the MOSFETs on the 12 amp hour. The 8 amp hour definitely does not have that, but it's still a pretty long board compared to this aftermarket replacement Milwaukee board. That's just a basic, say 4.0 or 5.0 pack type board. You can see that it still is longer. So therefore the push button wouldn't line up, by the way, on the fuel gauge. So we do see differences in these boards, but a really big difference in the 12 amp hour, including the top lid here. Just look at the length of the battery to get all 15 of those cells in there, of course. Just makes that pack that much more interesting to me. So looking at the board here, we do see a pretty similar layout or design, other than the MOSFETs though. All the charging part and the MOSFETs, and we still have the same style cell monitoring chip and the same style processor. This board just does have a different, or a thicker looking coating. It's just a really thick conformal coating. And we definitely see some different color cells, and the cells almost look like the 30T Samsung cells. So let's check the individual cells here, and we're getting 3.89 volts, 3.85, 3.9. That's looking pretty good. Ooh, 0.02. Wow, those are shot. All right, let's see here. And 3.9. So we probably do have a good many good cells in here, at least one, if not two bad ones. Let's just try to charge it up really quick and just see. Similar process as before, just putting 4 volts across it with a limited current. They're getting warm. Let's see if they're dropping off fast. Yeah, like a rock. So we're dropping off to the point that internally we have a issue with at least one, if not both, of those cells. So let's try to go ahead and remove these cells. We'll pop off these nickel strips and see if we can possibly just remove these 2 cells by themselves here. Being very careful not to touch across cell bank to cell bank, and not letting my screwdriver or these little flat nose needle nose go across the cell banks. And as we peel back the nickel strip, maybe we can pull out this little rubber bumper. Well, you know what? This bumper looks like it's actually connected all the way through. Oops. So yeah, don't do that. So I'm going to push these out, and it looks like that little rubber carrier or bumper went all the way through. That's kind of neat. I'm going to show really quick here putting super glue on this. I got several of them, but super glue does great with rubber, so we'll set it over here to cure. I'm just going to take 2 of these charged 4,000 milliamp cells and just stick them in here to see if I can get the air to clear on the pack. Of course, these cells are the 3,000. This looks like it's really a 6 amp hour pack. So again, this is just to see if the pack will clear, and it doesn't. We still get our blinking first LED. So what do you think it'll take to clear this? What if we lift up the plus and the minus tabs and just remove all the voltage from the pack and train it down? Reconnect it back like we are totally clearing it out. Everything's touching. Now we get no light. So let's go ahead and take this board off and look at it. I don't have any 3 amp hour cells to put on this board anyway, and I got some other ideas for the pack. Again, just being very careful here not to come across any of the 2 cell banks with any tool. And here's our board. And if I take 20 volts from my power supply and put across this board, we do see we're not getting any light, like the board's just dead. Show here with the meter right at 20 volts, and the polarity is correct. So this is a aftermarket, like 4 or 5 amp hour type or style BMS board for the M18. I ordered this from eBay. The difference in these aftermarket boards is the fuel gauge still works with just the voltage across the terminals. It automatically resets and shows you level. Now these boards will not allow the tool to work or charge with just the plus and minus connected, so it does have that safety feature built in. I have tested that, by the way. So if we bring over the Milwaukee 12 amp hour board, it does the same thing, 20 volts, but it's acting like it's dead or asleep. So what do you think it'll take to get these to reset? So I'm going to bring over an actual Milwaukee battery just to have a true DC 20 volts, because I'm going to put this board on the charger. So I didn't want my AC supply to be connected to it while I put it on the charger. So we'll take our yellow and go to our plus. I need to go to the back of the board like so. Green and go to the minus. As you see here, we have nothing like before. Let's bring the charger over, and I'll try to do this on camera. Hopefully the jumper will stay here. We'll try to connect the charging terminals. The plus terminal does not connect. It's just the other four. And as you can see here, it shows like it's picking up the 20 volts is full. Of course, like any Milwaukee battery, if you push the button while on charge, it doesn't show. But if we gently take this out now, is it going to be reset? Yep. So now it shows that we have a cell issue again, but the microcontroller, the board is all working. It just popped off. So let's hook this back up. It'll probably prove again that, yep, it's like it's dead again. So let's stick it back on there one more time. As you can see here, the plus is not used on the charger because it has its own charge terminal. The MOSFET connects through. Let's gently pull it back off. Is it blinking now? So yep, the charge is what it takes to reset these, by the way. And I probably could have tried to do this earlier when I had the cells just in there, and it actually may have just reset just to show the board being in a reset condition. So just remember that the charger can get you out of a fault condition that the battery won't reset with. Now off camera, I did go through and test all of these 3 amp hour cells, and all of them but 2, as you can see in the top right, tested good. So just 2 bad cells. The rest of these all tested quite well, really close to 2900 milliamp hours. So I did get 8 good 3 amp hour 21700s out of it, the 30T cells. So not a bad deal, but it didn't help me on my video. So just to show you here, I did actually buy an 8 amp hour battery. So just so you can see, I did try to make this a repair video. If I could have got some used cells like the 12 amp hour, I just could have repaired that pack. So I definitely wanted to share this with you, and also just take a minute here to share that nothing against the Ranger Tools USA store. I contacted them about the issue, the 8 amp hour, and I didn't know what happened, but I got 3 amp hour cells, so I must have got a 6 amp hour guts. I knew it was broken, so I was hoping they would kind of work with me and either swapping out some cells or giving me a deal on another 8 amp hour or something. And to be honest, they fired back and they offered a total refund. So I didn't accept it because I do have a use for the cells and they have value to me. To give them credit, as you can see here, they apologized and said, I understand completely. Request a return and we'll refund your money. So very good of them. They were going to make it right. Of course, I put back, you're too kind. The sales are way too good for me to feel okay about getting a refund. And as you can even see here on video, I had already taken them apart at this point. But they did indeed offer to make it right. And they even put back, at the end, they said it's important that their customer be satisfied. So they didn't seem to have anything that would work out to swap out, and I wish it would have worked that way, but it didn't. So we have some other options here. One thing I want to share with you is surprising to me that you can actually get these 21700 battery covers and do-it-yourself kits. This is basically a 12 amp hour aftermarket little kit. I know the quality is not going to be what the M18 is, but for $30 we're getting a board like I shared a picture of earlier in the video, and you're getting the cage and the housing, the nickel strips. So it's possible to take these 21700s or buy some new T3 style and make your own pack. Pretty reasonable. I mean, it's an option. I'm not in any way saying it's the best option, but for $29 and then with the price break of $525 after 10, so by 15 you're talking about less than $80. A little bit of shipping there, but if you can do it all for $90 and then $29 for the kit. That's still less than half price of a new battery now, whether that's an option you want to take. But it's an option, and it's always good to have a secondary option, even if the batteries somehow get where they're not available. Because you see here, Home Depot has it for $249, and even if you buy two, it's $498 at the time of the filming of this video. So basically, it's hard to get a deal better than $250 on that 12 amp hour, and the 8 amp hour is almost $200. So I guess that's one reason why these sell so high being broken. As I was trying to find on eBay, I found one that was just totally destroyed, and it still was almost $40. So people are paying up to $50-$60 with shipping and all for these broken 8 amp hour packs, and I really don't know that the sales are worth that even brand new. Matter of fact, just barely. So looking at the price of a new pack, it does seem like it's worth it. But here we have another option as well. We have, again, surprisingly, we have 21700 do-it-yourself kit that is for the 10 cells. Well, you could do a 6 amp hour, but we could also do an 8 amp hour. So take the same cells we just discussed, right? Same price, because if you buy 10, it'll be $525. So $52.50 plus the $25 for the kit. You're still talking about less than $80-$85 shipping and all, and you can build a pack. Even though it's an aftermarket board and lighter duty case, it's actually the good cells. The T3 series, I think it's a better option than like this aftermarket battery on Amazon. I mean, $80 is a good deal when you look at it from $200 for the Milwaukee. But one thing about this battery is I can't find anywhere in the description that says there's 21700 cells. So I can't say if it is or isn't, but I would bet that it's not, since it doesn't claim to be, because I think if it was, it would say so. We still have one more option, so check this out. At the time of the filming of this video, for less than $95, you can get a M18 8.0 high output for 72% off. So under $95, you can get an actual Milwaukee 8 amp hour. And this is the high output, so it's 21700 cells. It almost looks too good to be true for this price, but I tell you, I'm going to put this link down in the description. Click on it and look for yourself. It's over 1,000 sold this week, and I got to looking at how many 5-star ratings. And just check out the reviews for yourself. It looks like everybody is getting these in a little plastic baggie, and they are the actual legitimate Milwaukee, at least the best of their knowledge. So I think I'm going to order one of these as well as the kits. I think I'm also going to order some LiPo batteries, and maybe offer to do a video on something I've done in the past. It was kind of make your own power stack cells. Even though this is not a high amp hour battery, it's kind of neat to be able to make your own replaceable battery, and a battery you can take the pack apart and actually charge this on a hobby charger. Or I mean, it just opens up some other doors, right? It's just another option. So that broken case that I have, I've done this before where I had a case in bad shape. I just simply made use of the case and the connections to make a battery kind of like this. And you can make it easily be disconnected and charge it in different ways. And it's actually hooked up to an actual Milwaukee board. So this is just an example of one modified and how it don't come on. And then after charging it for a second, the lights come on, and it's a fully functional Milwaukee battery. It's got a lot of output current capability. It just doesn't have much capacity. But I'm thinking if I measured right, I might be able to get two of these in the 8 amp hour case. It'll be a pretty neat 3 amp hour pack because it'll be so easy to work on and replace. You can basically make this pack last, I mean, indefinitely. So this video is getting very long, so let me know down in the comments which direction you would like to see in the next video, because I do want to finish with a repair. I can buy cells and make a 12 amp hour battery and see how it looks. I'm going to buy that 8 amp hour battery and see how it does. I'm going to buy the 8 amp hour kit and probably put these good cells from the 12 amp hour in it to make a good 8 amp hour battery, and we can see how it does. If you're interested, I could even show how I do the LiPo battery to make a really convenient and easy to work on pack out of it. It's not the most compact and the best for size, but it is very handy to have one like that for being able to work on, replace, and charge by other means. So I hope you found this video helpful, or at least interesting. If you did, please like, share, and subscribe. I'm going to have some of these links down in the video description, as well as some other tools and interesting items that I find helpful on my workbench. And any of those links you click on are affiliate links. and they help support the channel, and I greatly appreciate it. So thanks so much for watching, and God bless.